Hello, chemistry students. We got snowed in, so we figured we'd just make a video. So we're gonna go through the 5 types of reactions and we're gonna balance them. First one we're gonna see is synthesis. All right, we have aluminum plus oxygen forming aluminum oxide. All right, big thing to look out for: one product in a synthesis reaction. All right, so we're gonna have to rewrite all of these names as the formulas. Aluminum is just Al. Oxygen is part of those diatomic molecules, so it should be O2. And aluminum oxide, so we still need to know our nomenclature rules. Aluminum's gonna take the +3 charge, oxygen the -2. We're gonna whoop them. The formula should be Al2O3. All right, so 2 reactants, 1 product. We're gonna go to balance it. All right, there's 2 aluminums as a product, but only 1 that we're starting with. There's 3 oxygens as a product, but only 2 that we're starting with, so that's an issue. The first thing I'm gonna do is I'm gonna put a 2 in front of here, because there's only 2 oxygen and there's 3 over here, so we're gonna need to get it to be an even number. So 2 times 3 is gonna give me 6, so I'm gonna put a 3 over here, 3 times 2, so 6 oxygen as reactant, 6 as a product. All right, now for the aluminum, there's 2 in the compound, but there's 2 compounds with that coefficient. So when we multiply, we're gonna have 4 aluminum. So 4 aluminum plus 3 oxygen yields 2 aluminum oxide. All right. Now we're gonna look at decomposition. It's the opposite of synthesis. 1 reactant forming multiple products. Sodium hydroxide forming sodium oxide plus water. All right, sodium hydroxide, NaOH. Hydroxide, again, that's from that list of polyatomics that we know. Sodium oxide, it's a binary ionic compound. Sodium's gonna be +1, oxygen's gonna be -2. We're gonna whoop. So this is gonna be Na2O, and water is H2O. All right, now this one's gonna look a little tricky, but we're gonna balance it. There's 2 sodiums as a product, so we need 2 sodiums as a reactant, so I'm just gonna put that 2 there. All right, now if I look at my oxygen, if I have 2 sodium hydroxides, I have 2 oxygen, I have 2 hydrogen. Look at that, I have an oxygen here, an oxygen there. So I do have 2 oxygen, and I have 2 hydrogen. So this one is a pretty simple balance. It only took 1 coefficient. All right, so again, decomposition, 1 reactant, multiple products. All right, so now we're gonna look at single replacement. All right, we got aluminum plus copper 2 chloride forming copper plus aluminum chloride. The aluminum, that's Al. Copper 2 chloride, chloride's a -1, copper is +2, so that's CuCl2. All right, we have pure copper, and we have aluminum chloride. The aluminum's +3, so when we whoop, this is gonna be AlCl3. Typically, not always, but typically, metals replace each other in a single replacement reaction. We have an element, a pure element, and a compound forming a pure element and a compound. It's a new element, all right, that we form. It's kind of like copper's dating chloride, and then aluminum kind of kicks copper out. Copper's by itself, it's lonely. Aluminum's now with chloride, it's like, woohoo. All right, we're gonna balance it. Same issue. Chlorine's going from 2 to 3. All right, so what we're gonna do is if I put a 2 here, that'll become 6 chlorides. And if I put a 3 here, I'll have 6 chlorides. All right, so we get a common factor. So now that means we have 3 copper, so we put the 3 there. We have 2 aluminum, so we put the 2 there. So that's not that bad. Our 4th type of reaction is double replacement. It's like the single, but now both will be compounds. Lead 2 nitrate, PbNO3 2. Potassium chloride, that's just going to be KCl. It's going to form potassium nitrate, KNO3. And we're going to get lead 2 chloride, PbCl2. In this reaction, the lead and the potassium are going to switch spots. All right, so again, the metals replace each other. So the potassium is now with the nitrate, and the lead is now with the chloride. We've gone from having 1 chloride to 2, so we're going to put a 2 in front of the KCl. We've gone from having 2 nitrates to only 1, and we also have 2 potassiums, so we'll just put a 2 in front of there, and this one is balanced. 1 lead, 2 nitrate, 2 nitrate, 2 potassium, 2 chlorine, 2 chlorine. Last reaction, combustion. Combustion is always a carbon-based fuel plus oxygen forming carbon dioxide and water. The carbon fuel we're going to use is propane. I know you guys don't know what propane is, not yet, so we're going to give you those formulas. That's going to be C3H8. We're going to add oxygen to it. Carbon dioxide is CO2, and water is H2O. We need to balance. If we look on the product side, we have 1 carbon, we have 2 hydrogens, we have 3 oxygens. Balancing a combustion reaction as easy as 1, 2, 3. All right, so however many carbons we start with, 3, we're going to put that in front of the carbon dioxide. However many hydrogens we start with, which is 8, we're going to have that and put it in front of the H2O, so we're going to get a 4 there, so 4 times 2 will give us 8. We'll recount our oxygen. 3 times 2 equals 6, plus 4 times 1. So we have 10 oxygen atoms, so we're going to need 10 here. So we're going to put a 5 in front of the oxygen, and that is our combustion reaction. Sometimes we'll see slightly trickier combustion reactions, and we will see some other stuff with balancing, but that's the 5 types and balancing in a nutshell.